As you reach the final stretch of your journey through the essential vocabulary of the valves industry, it's time to reinforce the knowledge that will empower you to communicate with precision and confidence in any role, be it operations, design, maintenance, service, or safety. Let's explore cards 76 through 100, each representing a cornerstone concept that shapes the world of valves. Understanding the backseat test procedure is crucial for safe maintenance. When a valve is fully open, the backseat provides an additional seal, preventing leaks from the gland area. This is especially important during maintenance activities, such as replacing stem packing while the system remains pressurized. By performing the backseat test, technicians can confirm that the backseat is functioning as intended, ensuring safety and operational integrity. Zero leakage classification stands as the gold standard for valve sealing performance. Valves rated for zero leakage, often referred to as Class 6 or bubble tight, are designed to prevent any measurable flow through the closed seat. This is particularly vital in applications involving hazardous or toxic media, such as chlorine gas, where even the smallest leak can pose significant risks to personnel and the environment. Stem thread galling is a form of mechanical wear that can compromise the reliability of a valve. Galling occurs when the threads on the valve stem are damaged due to friction, often exacerbated by insufficient lubrication. Recognizing and preventing stem thread galling is essential during both assembly and maintenance, as it can lead to operational difficulties or even valve failure. Limit switch setting is a key aspect of automated valve systems. Limit switches serve as indicators, signaling when a valve has reached its fully open or closed position. Proper adjustment of these switches ensures accurate feedback to control systems, such as SCADA, and helps synchronize valve movement with broader process automation. Trim material compatibility is a fundamental consideration in valve selection. The trim, comprising internal components like seats, discs, and stems, must be compatible with the process fluid to resist corrosion, erosion, and wear. Ensuring compatibility extends the service life of the valve and prevents costly failures, especially in challenging environments like acidic slurries. The torque-to-thrust ratio is a technical parameter that links the rotational force, torque, applied to a valve actuator with the resulting axial force, a thrust, on the stem. This ratio is critical when sizing actuators, as it determines the mechanical advantage needed to operate the valve reliably under varying conditions. Changes in stem design or thread pitch can affect this ratio, necessitating recalculations to maintain optimal performance. An anti-blowout stem feature is a vital safety mechanism, particularly in high-pressure applications. This design ensures that the valve stem cannot be ejected from the body, even if internal pressure rises unexpectedly. The anti-blowout feature protects both personnel and equipment, reinforcing the valve's integrity during both normal operation and unforeseen incidents. Valve stroke speed setting controls how quickly a valve opens or closes. In systems sensitive to pressure surges, such as water pipelines, adjusting the stroke speed helps prevent phenomena like water hammer, which can damage equipment and disrupt operations. Fine-tuning this setting allows for smooth transitions and protects the system from abrupt pressure changes. A pressure balancing plug is a specialized design element found in globe valves. By equalizing pressure across the valve plug, this feature reduces the force required to operate the valve, making it easier to open or close under high-pressure conditions. This not only eases actuator load, but also enhances control accuracy in throttling applications. Test bench calibration is the process of verifying and adjusting valve testing equipment to ensure accurate performance measurements. Before conducting tests like hydrostatic or seat leakage checks, calibrating the test bench guarantees that results are reliable and meet industry standards, supporting quality assurance throughout the manufacturing and maintenance lifecycle. Valve maintenance interval refers to the recommended period between scheduled inspections or servicing activities. Adhering to these intervals is essential for preventing unexpected failures and optimizing the total cost of ownership. Extending maintenance intervals without proper diagnostics can lead to undetected wear or damage, increasing the risk of operational disruptions. Sealing surface lapping is a precision finishing process used to restore or enhance the tightness of metal-to-metal sealing surfaces within a valve. By carefully lapping these surfaces, technicians can achieve a high level of flatness and smoothness, ensuring leak-tight shutoff even in demanding applications that require stringent shutoff classes. Inline valve serviceability is a design advantage that allows internal components of a valve to be repaired or replaced without removing the valve from the pipeline. This feature is highly valued in facilities with complex or space-constrained layouts, as it minimizes downtime and reduces the effort required for routine maintenance. Pressure relief gap check involves inspecting the clearance and pressure relief valve components to ensure they meet safety thresholds. This check is a critical part of pre-commissioning audits, confirming that the valve will function reliably under overpressure conditions and protect both equipment and personnel. Electrical actuator enclosure rating defines the level of protection provided by the actuator housing against environmental factors such as dust and water. Ratings like IP67 or IP68 indicate suitability for specific conditions, such as outdoor installations or underground pits, safeguarding the actuator's performance and longevity. Self-relieving seat design is a safety feature in certain valve types, such as ball valves, that automatically releases excess pressure trapped in the valve cavity. This prevents dangerous pressure buildup, particularly in double block and bleed applications, and contributes to overall system safety. Air-fail position configuration determines the default position of an air-operated valve in the event of air supply loss. Depending on process requirements, the valve can be set to fail open or fail close, ensuring that the system responds appropriately during power or instrument air outages. The valve part numbering system provides a structured method for identifying and cataloging valves based on type, size, trim, and material. This system enhances traceability, simplifies inventory management, and streamlines the procurement and maintenance processes. Mounting flange standardization, such as ISO 5211, ensures that actuators and gear operators can be easily mounted across different valve models. Standardization facilitates retrofitting and upgrades, enabling greater flexibility and compatibility within plant operations. Locking lever installation introduces a manual locking mechanism to prevent accidental or unauthorized valve operation. This safety measure is commonly applied to drain and isolation valves, supporting compliance with safety protocols and preventing unintended process interruptions. Valve cleaning and flushing is a preparatory process that removes contaminants like debris, grease, or mill scale from new or serviced valves before they are put into operation. Proper cleaning ensures that valves perform as intended and reduces the risk of contamination or malfunction. Torque limiter function is a protective feature in actuators that halts movement once a predetermined torque threshold is reached. This prevents over-tightening or mechanical damage when the valve reaches its travel limits, safeguarding both the valve and the actuator. A material test certificate, or MTC, is a document that certifies the chemical composition and mechanical properties of valve components. Verifying MTCs before installation is a key quality assurance step, ensuring that materials meet specified standards for safety and performance. Valve seat material upgrade involves replacing existing seat materials with more resilient or compatible options to address issues such as erosion, corrosion, or wear. Upgrading seat materials can significantly extend valve life and improve operational reliability. Finally, the commissioning test plan is a comprehensive checklist of inspections and functional tests performed before a valve is declared ready for service. This plan typically includes stroke checks, pressure testing, and integration with control systems, ensuring that every valve meets performance and safety requirements before entering operation. With these final concepts, you have completed a robust foundation in valve industry terminology. This knowledge will serve as a powerful tool, enabling clear, effective communication and supporting excellence in every aspect of valve operations, maintenance, and management. Congratulations on your achievement. May your expertise open new doors in your professional journey.